Well, everyone, just wanted to say thanks again for joining us for this information session on the certificate in machine learning that's offered through York University School of Continuing Studies. My name is Sean Woodhead, and I'm the program manager for certificate machine learning here at York. So you'll see that I've put up an artist rendering of a building up on the screen there. Now, this building is what has been recently approved by the York University Board of Governors as the new home for continuing studies programming at York. I mention this because we do sit at an interesting time in continuing studies programming in Canada. So while many continuing studies departments are closing their doors, we're building and expanding. We find ourselves in this good position in part because of how we conceptualize and develop quality educational programming. Today, it matters much more what you can do than simply what you know. Our programs acknowledge this and embrace it. The certificate machine learning has designed its curriculum around what we want you to demonstrate by the end of the program. I'll get into that more in a bit, but those things that we want you to be able to demonstrate are exactly the competencies that various industry leaders and hiring managers told us were critical for someone to be successful in a machine learning related role. And as I said before, I'll get into that more in just a bit. So I just want to go over the agenda really quickly for today's session. So first, I should mention that we are trying out a new format. Traditionally, we offer an information session that runs through the different details of the program, and I believe we'll still seek to accomplish that today. But I want to try and accomplish that partially through a different method, which will be an interview with one of our instructors. Before we get to that, just a couple quick items. First, during the session, all participant microphones are muted, and that's just to reduce the ambient noise so that you can hear us clearly. Second, at the end of the session, there will be an opportunity for questions or comments. You can put your questions into the questions function, and that's located near the bottom of the GoToWebinar screen. If for whatever reason, though, if we run tight for time at the end, what I will do is I'll email each of you the answers to all the different questions that you've asked. So I guess without further ado, let's begin. So I'd like to just introduce you now to our special guest, and his name is Hashmat Rohian. Hashmat is the Senior Director and Managing Enterprise Architect at the Cooperators Group. For over 10 years, he has effectively led initiatives that have involved rapid advancement in data, analytics, digital, and business leadership. As a technology enthusiast and lean startup evangelist, he is renowned for building a never rest, kill complexity, and care more culture that manages the existing technical debt and prepares the organization for future disruptions by leveraging emerging business models and digital ecosystems. Hashmat is also a published data scientist, IT and agile delivery practitioner, and academic, with many years of teaching and curriculum development experience at colleges and universities in Canada. He is also the co-founder of a startup called Disrupt IT Labs, Inc. He's also organized conferences and workshops and being interviewed on print, radio, social media, and TV as an analytics expert. And I should also mention that Hashmat recently won the Instructor Leadership Award at York University School of Continuing Studies for his excellent leadership in our Big Data Analytics program. Welcome, Hashmat.
Thank you, John.
So I just wanted to start off by asking about the emergence of machine learning in the working world. So sure, there might be a lot of talk about the rise of the robots and lots of talk about sentient beings and machine learning rendering us feeble humans as imminently obsolete. But then I understand that many new to the field are in fact surprised when they hear that machine learning has existed since the 1950s. So I mean, certainly machine learning has garnered a lot of attention. So that attention or that hype, if we want to call it that, um, why is that? Why is that happening now if machine learning has existed for so long? What's changed?
What has changed has, Sean, first of all, thank you for the very kind introduction. What has really changed is if I can frame it, on the hardware side, we have a lot more technology. The Moore's law has taken over. Things that such as deep learning, which were not feasible a few decades ago, is now feasible with the graphical processing units, with cloud providers offering, you don't have to buy a lot of infrastructure to do a lot of analytics project. So on the hardware side, that is the one driver of this. The second part is on the software side, with new languages, with languages such as R and Python, which are open sourced, has a great community both in academia as well as in the industry that is constantly growing. That also has helped drive this, rise of the machine learning. And the fourth industrial revolution, for a lack of a better word, is the fact that we have sensors everywhere. We have sensors on our smartphone, we have sensors on our watches, we have sensors on our fridge, we have sensors everywhere, and we are inundated with all the amount of data that's being produced everywhere. So the variety, the velocity and the volume of data has kind of overtaken us. And now the question is, what do we do with that? Right? And how can we use data as some have called it, the oil of the 21st century? How can we actually add value to our existing businesses and come up with new business models using data? So another rise is, the differentiator with Amazons of the world, with Facebooks of the world, who are hoarding data and using that as the next as that competitive advantage for that business model. That is kind of forcing every enterprise to relook at their value proposition and saying, okay, how are we leveraging our existing capabilities in data? How are we better understanding our customers, client, their needs, our communities, how well our different business units do? How can we make better decisions faster and cheaper? And data, with the amount of, with the cheap availability of hardware, as well as open availability of open ecosystems for languages and software, have helped this drive. And also the fact that, nowadays people's preferences and expectations have changed. There are folks, there's once the best experience that a customer demands is the last best experience he had had. That's kind of become the base now. So anytime you go on Netflix and you watch a movie and it tells you what other movies or show you should watch, that similar experience everybody demands from their insurance company, from government, from public sector, everywhere. There's an expectation from population to actually to add value using their data, to saying, well, that was the customer experience I've got used to, especially with millennials and Gen Zs. I expect that from my vendor of choice, from my partner, from someone I purchase things, or from my government. So that is also driving adoption of machine learning. It's kind of like, how can we not be inundated by this data? Humans alone can't do this. How can we leverage machines to help us make decisions better and faster and come up with new value propositions?
So that the adoption of machine learning, certainly its growth has been exponential if you look back across, let's say, the last decade or so. So I want to ask specifically about, in your case, what drew you into analytics and more broadly into data science? Was this sort of some serendipitous adventure, or was it something that you had planned for a while? And the reason I'm asking is because, was it even possible to foresee what data science would be like today in 2018, back when you had decided that in fact this would be your career?
That's a great question. So absolutely not. I did not set out to become a data scientist. I'm a data scientist by accident. Data scientist as the sexiest job of the 21st century did not exist when I was doing my grad studies. At the time, I wanted to be one of the wolf of Wall Street and go and become a quant. That was the closest approximation to what we call data scientists, to leverage lots of data and to come up with pricing mechanisms to come up for complex derivatives. when then we had the 2008 incident and financial systems crashed. And I did my advanced degree in computer science engineering, and I went to business school for financial engineering. So I actually ended up with two really core competencies: one in technology and one in stats and math and probability. So I had a good foundation there. And what I was always intrigued by is how humans make decisions. So I actually I actually took several courses in human behavior and behavioral economics as well, understanding how people actually make decisions, how companies make decisions, how can we improve those decision-making mechanisms, make them more evidence-based, make them more fact-based, go away from the gut instinct and the year-long planning cycles that some organizations have got used to, where other organizations like Amazon or Google or Facebook and Netflix have come and disrupted them. So what prompted me to hit the data science field was I was always intrigued by how organizations make decisions and how we can improve that decision-making methodology through data, through evidence. And the competencies that I have had acquired through my education, and I'm an alumnus from York University as well, actually helped me kind of come in and kind of put those two competencies together and help organization make better decisions faster using data that they either had collected, they had harvested through their partners, or purchased. And so that when you go to a board meeting, everybody's not reading off multiple hymn sheets, but actually have one single view of a customer, a single view of a product, a single view of a business unit, and actually make decisions based off of a single view of what the reality is. One of the things I noticed earlier in my career was I started off as management consultant was, there was always this phenomenon called HIPPO, which is the highest paid person's opinion. And it was very difficult sometimes to challenge the status quo, because there's this consensus in the industry saying, if you are paying the highest in a room, you must be making the best decisions. And that's not always the best way to frame. Are you actually making evidence-based? Or are you actually, is it your gut instinct? One of the things I noticed a lot when I was having conversations during my initial jobs as data scientist and building data science team was, I used to ask, why are we doing this? I would ask a lot of why questions. So curiosity is absolutely a must in data science. Why are we doing this? And lots of the 5 why principle. And when you cut to the chase, people would say, well, we're doing it because we've always done it this way. And that was the worst answer I would get to. I was like, okay, that would have been true 30 years ago or 20 years ago or a decade ago. But with the advent of new business models, with the advent of new technologies and new customer preferences, and everyone disrupting you, whether it's Google or Amazon, and Amazon is disrupting almost everybody. Is it the right way to think about how you make decisions? Critical decisions, not only for the business, but for your clients as well as your stakeholders and your shareholders. So that kind of prompted me to get into the data science.
I want to go back to the comment that you made. So you juxtaposed human decision making with machine decision making, and that businesses are better when they make evidence-based decisions. And I think virtually all of us could agree with that. So with the exponential increase of bringing machine learning solutions into our business processes, where in fact is there still room then for humans to participate in decision making?
I think there is a lot of talk right now about artificial intelligence. I mean, if some of the most the smartest people in the world, like Stephen Hawking or Bill Gates or Elon Musk, would tell you AI is going to destroy us. Artificial intelligence is going to be kind of like some of the Terminator movie we have seen. I like to distinguish artificial intelligence into 4 different categories, or a few different categories to begin. There's of course artificial intelligence, but it's a spectrum. There's assisted intelligence. There's autonomous intelligence, right? And there are different kind of intelligences which kind of combined could actually help make information more readily available and decision making easily available to industries and companies. So depending on which part of the spectrum you are, very few organization have got to the point where, machines can make all decisions for them. I think the most important thing is, a lot of the artificial intelligence or machine learning actually is in place as an assisted intelligence to kind of take off those tasks off of a knowledge worker that are menial, that are things that can be automated. So it starts with things like robotic process automation. Like, if you're going to do this over and over again, why are you doing it? Shouldn't there be a robotic process automation that can just take care of it? So a lot of organizations start with that. That's kind of the base stuff. They gather data, they observe behavior, and then they automate the process. Then it moves on to more of what we call assisted intelligence, so chatbots, these kind of things. Can it assist? It's not so much to replace people, but hey, can we assist our existing knowledge base workers to actually do more of the value add tasks rather than do more of the menial tasks? And then from that forward, it kind of goes to automated intelligence, where can we start creating single view of things, whether it's client, whether it's risk, whatever it is. Can we all come to the same definition of things? So this is where data governance comes in. This is where data quality comes in, making sure we are reading or singing off the same hymn sheet so that everybody has a singular view of things. So that's kind of the automated intelligence, and that's where a lot of machine learning goes, and kind of figuring out what are the different options, helping humans explore all the different options. So for example, when you do a Monte Carlo simulation, a human being with a paper and a pen cannot go and talk through thousands and hundreds of thousands of different scenarios and kind of work through all of that. So can a machine help us run those? Because machine, frankly, if you give it enough compute and enough memory and some hardware or hard disk, can go through all those and doesn't get tired, doesn't complain. So those kind of tasks have become automated. And slowly what has emerged over and kind of getting close to the prescriptive analytics is recommendation systems, right? Systems where it adds value. So for example, if I've watched a certain trying to find patterns within your behavior and transactions and come up with new insights and new recommendations. For example, recommendations engines are everywhere. That is a prime example of machine learning. Another example would be, for example, where do we deploy a police force? For example, where should they deploy their folks, to fight crime? Are there better ways to allocate their resources, whether it's an insurance company after a major incident? How do we better allocate? Given that all the data is coming, we have sensors everywhere. Sensors could be your social media. So for example, when there's a hurricane or a flood, a lot of insurance carriers look at the social media tweets, and that kind of gives them a signal. And machine learning helps remove the noise from the signal and helps them kind of say, okay, that those are the locations where we need to put our beer tent. Those are the locations we need to send our claim adjuster. So that's kind of how machine learning has come in and helped across the spectrum of decision making. It has yet to actually replace human beings, although over the next 5, 10, 20 years, with the advent of autonomous vehicles, there will be some jobs will be disrupted, and some jobs already have been disrupted. Some industries have been disrupted with Airbnb and Uber. Existing business models have been disrupted, like taxi driver and medallion, and all of those are no longer worth millions of dollars, but have kind of crashed because Uber has come up with a new business model that is fueled by data, that is fueled by technology, and that's fueled by machine learning. That's how you get search pricing. So I mean, if you think about search pricing, how does Uber know when to search something? Where do they get their signals from? Machine learning has enabled that business model. So there have been new business models. There's as much in machine learning that has tried to replace existing business models as new business models have emerged. So Amazon, Facebook. I mean, if you think about Facebook's business model, it's a great business model. You don't pay anything, but the data that you're feeding that machine and kind of voluntarily feeding that machine is actually allowing that ecosystem to come up with new business propositions and monetize that data in different ways. And machine learning is allowing you to do that. So if you take a picture and it auto tags you, it says, oh, someone posted a picture, a friend of yours posted a picture, and I think you are in that picture. That experience could not have been imagined 10 years ago. But now with machine learning, that experience is common practice. More most cameras now have that feature where when you take a picture, it will self-tag you on those. So machine learning has not replaced human beings, I don't think, but it has definitely assisted and started making humans much more productive. There are research papers that show in the next decade, the productivity will grow by 40%, aided by artificial intelligence and machine learning.
So the piece around disruptions, you already you mentioned a few industries that have certainly been disrupted where perhaps data science related jobs replaced the more manual labor that was taking place within those industries. And so I want to address something head on with you. I've read recently one article in particular that came up in my LinkedIn feed that even data science itself could be disrupted by machine learning. Now, the article went on to say that it is certainly where the disruption could be would be those unidimensional programmers who only know the technical piece. So when I went through the beginning stages of developing the certificate machine learning program, I had consulted with a number of different industry leaders in the Toronto area and hiring managers, people who are hiring data scientists, machine learning engineers. They had identified some gaps that they were hoping our program would fill. So they cited issues with the data scientists and machine learning engineers coming in, not being able to navigate ambiguity in the workplace. They were approaching the business problems more as research problems, and they were not able to support the more senior decision makers in identifying even what business problems can be solved with the data that they have. How could they perhaps go about acquiring more robust data and having better quality data pipelines to support the machine learning and the analytics side, et cetera. So my question is about cross-functional skills. So, I mean, it was clear to me, based on the feedback we got, that it is imperative that people be able to graduate our program having not just the technical skills and know-how, but that there's also a business dimension and an ethics dimension. Is there anything that you think is particularly remarkable about what we've done in this regard so far with curriculum development for the certificate machine learning program?
Absolutely. So you raised some really good points, and I just want to reiterate those before answering your question. So first point you made, which was around this data science being disrupted. Absolutely. Any function that over time will be disrupted, what it will be disrupted would be with higher order functions. So some of the higher order functions you talked about are understanding the business domain, framing the business problem, understanding the ethical issues, the privacy issues, the legal framework that you're working within. So that's number one. And the second thing I would also add is, as you are, as you mentioned in terms of your question, the key differentiator between a data scientist, there is also this common adage in the data science world, and it's kind of a dig in the whole data science field. It says a data scientist is a statistician who knows a bit of programming, or a programmer who knows a bit of statistics. So if that is the frame of reference for a data scientist, absolutely, that is prime for disruption. A data scientist is much more than a statistician with some programming skill, or vice versa. It is someone who understands deeply the business, understands how the current state of how the business model works, understand the stakeholder, understands the legal framework that they operate, understands where the issues in terms of where the issues of concern, where the pain points are, and it can understand what decisions and it can take a business problem and frame it as an analytic problem. That's the key skill that any data scientist worth their salt would gain over years of experience or through a curriculum that we have developed. That is definitely one of the differentiators when I look at many other programs, both in Canada, MOOCs, as well as online courses, is one of the things that is very difficult to transfer and train is on those higher order functions, those higher order competencies, like understanding the business context, understanding how do you frame a data problem or a business problem to a data problem or an analytic problem, how do you harvest, how do you influence and sell an idea. One of the great statisticians also have a very popular saying which says all models are wrong and machine learning generates models. All models are wrong, some are useful. And I would just add to that, some are, even fewer are usable. So all models are wrong. Every machine learning model that you see is a generalization over a lot, tons and tons of data. Most of them, all of them are wrong to some extent. There are ethical issues involved in them that we have to circumvent. There are a lot of other issues because it's a form of generalization. You're trying to generalize over a population and trying to apply it to a sample. But the key part that I want to add to that is not only are all models wrong, some are useful, even fewer of those useful ones are usable. And that's another skill, because you don't want to just go ahead and learn how to do Python and R or Hadoop or Spark, you name it. I mean, these TensorFlow or Tiano or Keras. It's not about the technology so much. It's about, okay, so what are you going to do with it? How much of what you do is usable? Let me give you an example. I have been working on several projects in my experience where we had found a model that worked at 97% accuracy. We could detect fraud, for example. But we found that there were ethical issues with it. One of the key variables that was a predictor of fraud was ethnicity. So we were like, that is not usable.
Yeah.
And we had to go back and we said, did we collect the right data? Did we bias our data collection? Because let me give you another example. There's a lot of models that basically right now, for example, there are models out in US where they help judges determine the sentencing for different people who are folks that show up in front of the judge, and those models have some biases because they gather data, and some of those data are weighted heavily towards one ethnicity over another ethnicity, and of course the sentencing reflects, so garbage in, garbage out. So how do you communicate the fact that data science don't think of machine learning as just a black box you feed in data and it's going to come up with some magical insight, but actually being able to understand the full cycle of how do you take data, take information from it, convert that information to knowledge, and then make decisions based on that knowledge. I mean, that cycle, that full cycle, that conversion from data into information, that's a lot of focus of a lot of online programs and even other graduate and continuing studies program is just kind of teaching people skills on how do you take data and convert it to information. How do you take lots of data, clean it up, and build models? That's cool. That's really cool. But it's still not usable or useful. You have to then take that knowledge, that information, convert it to knowledge, and then make decisions based on knowledge. Of course, being able to communicate and sell those ideas and those insights, and convert those insights into action points, decision points that can then be communicated and saying, this is what we're going to do. So one of the things that differentiates as I was working with my other colleagues on this program is the fact that we have a very diverse set of instructors in this program. We have instructors that come from Microsoft, from a large bank, that we have folks that are working with startups and financial services. They have lots of diverse competencies and experiences. And that is actually one of the key differentiator of this program. I'm sure you will talk about the other instructors. So one of the things that impressed me and wanted me to join the teaching faculty for this program was exactly that what we want folks is, what we want the graduates of this program are to be well versed, well rounded decision scientists, not data scientists. We want folks to be decision scientists to help organizations make better decisions. So not just about taking data, cleaning it up, running some deep learning model on it, and there you go. You can probably learn a lot of that on Coursera or any of those. But what are you going to do with that? How are you going to make it usable? How are you going to deploy it? How are you going to make sure that it's legal, it's ethical application of data, and actually serves a purpose?
Excellent. Well, Hashmat, I'm just looking at the time here. I think I have about 10 minutes to get through the rest of the stuff, but I really want to thank you for taking the time to chat with all of us. I'm really excited about the year ahead and what we'll be able to accomplish in this program and with our students. But thank you very much for chatting with us today. Okay, everyone. So I'm just going to move through the rest of the info session. I'm going to try and keep it to 10 minutes or so. I just want to remind you to use the questions feature when questions come up at any point in time through the rest of the presentation. We might not have time to get to any of those questions in this information session. And then just as I mentioned at the beginning, if I don't have time to respond to any of those questions during this session, what I will certainly do is email all of you the answers to those questions, and you would be able to expect that email by tomorrow. But just to start moving through the rest of this. So I have up on the screen a few different, what we believe to be differentiators of our program with some of the others that are somewhat related to the certificate in machine learning. The first one is an outcomes-based curriculum. So you might find across some different programs, they'll identify that they believe that students will demonstrate a series of outcomes or they'll achieve some objectives by the end of the program. We try to go a bit deeper than that. So we aim to guarantee that students will successfully demonstrate those learning outcomes by the end of the program by taking an outcomes-based approach to everything we do. So all the content that is delivered in the 4 courses, the assessment and evaluation that you go through, anything that's happening during one single minute in the program has to be meaningful, and with it being meaningful, it means it needs to ultimately funnel into those learning outcomes. So I've put up on the screen the first 5 of those learning outcomes. These learning outcomes, you can also read them up on the Certificate in Machine Learning webpage, and I'll have that URL available to you near the end of this information session. So the first 5 are there, and now I'll move to the last 4. And the culmination of these learning outcomes are really to graduate students who satisfy those technical, business, and ethical competencies that we mentioned during the interview. And we didn't come up with those on our own. In fact, we went through a process with various different companies, most of whom are in the GTA, and they were the ones who ultimately determined what our students will graduate with. And the reason that we took this approach was, 1, we wanted the certificate program to, of course, be meaningful, but 2, we wanted to give some assurances to those participating companies that our students will, in fact, have successfully demonstrated these learning outcomes upon graduation. And then that gives them greater faith in wanting to potentially hire our graduates. So the program really does have a vested interest in ensuring that if you successfully exit the program and get the certificate, that you have done you've achieved these 9 outcomes. So the next one that I'll just touch upon very briefly is experiential learning. Now, again, experiential learning it's a term that does get used a lot in education, especially today. And what I mean by experiential learning is that the time spent in the classroom is based more on what will you demonstrate through experience, and much less what will be disseminated to you in a very passive learning style. Now, I have up on the slide now, education fit to a T, the critical importance of cross-functional skills. This really touches upon that experiential learning piece. As I just mentioned a moment ago, especially around the business and the ethics, we heard from the various companies that this was a real gap. So we want to ensure that the certificate in machine learning is not just known as graduating you with a minimum level of competence in the technical areas of data science, but that it's more than that, that you can go in and you really can be transformative in helping guide whatever business you'll be working in, that you can guide them through the greater deployment of machine learning solutions in those businesses, or in that business. Now, developing a portfolio of business solutions, we see as another differentiator. So there are a number of programs where they will graduate students with a portfolio. Now, with our program, we're focused on real business problems, and particularly in the machine learning capstone, these are unsolved business problems. So we're working with businesses in the GTA and beyond, building pipelines of business problems into the program for students to work on, to present their solution for that problem, and when time permits, to even work on planning and maybe even the beginning stages of deployment with those businesses. So it's a win-win for our students. This gives them experience that they can go into an interview and say, this is the real solution that I came up with, and we even begun implementation on that solution. And instead of solving problems to business problems that may have already been solved and that perhaps many other students across different programs have also been working on. So we really see that as a unique feature for this program. But it's not just one business problem that you work on in this program. There are opportunities throughout the program to work on and solve other real world business problems. And at least one of those will be of your own choosing. So the format is also a differentiator. So we have a blended delivery format. And what I mean by the blended delivery format is that there's a face-to-face component, and then there's an online component as well. So the face-to-face component, that is, there's 7-hour classes that are concentrated into 1 3-day weekend every 2 months. And then the 7 weeks in between those face-to-face weekends, it's light online learning. So for the fall cohort, the face-to-face classes are scheduled for September 21st, 22nd, 23rd, November 16th, 17th, 18th, January 18th, 19th, 20th, March 15th, 16th, 17th, and then May 11th and 12th. And then with the winter cohort, there's the exact same frequency with class that begins on January 25th, and the winter cohort concludes on September 15th. So we went with this format after speaking with several prospective students. They said that this approach would allow them a lot of flexibility to maintain their work and personal priorities with minimal interruption. Okay. So another differentiator is just how much our program is connected to the community. So we work in various capacities with a number of organizations, and I have some of those organizations that are listed up on the screen right now. And I think some of the more notable ones would include Microsoft Canada, Scotiabank, Stack Adapt, Zero Gravity Labs, and I have all of them up on there. And we're continuing to build our complement of different organizations that are working with the program. So lastly, and I mean, Hashmat had touched upon this piece as well, it's our experienced instructional team. So I really do believe we have a great team here. Hashmat has done a great job with the big data analytics program that we also offer. And as I mentioned at the start of today, he recently won the Instructor Leadership Award at York University. But we also have some other instructors who have remarkable experience in data science and in instruction. So we also have Dr. Annie Lee, who's an instructor, and she currently is the lead research scientist at Vertical Scope Inc. here in Toronto. She has worked in data science and software development roles across multiple sectors. And then there's Dr. Karthik Kuber. So he's the instructor for the Machine Learning at Scale course. And he has previously taught at Syracuse University. And he's currently a data scientist with the Growth and Ecosystems Organization of Microsoft out in Seattle. And he's also a certified deep learning instructor with NVIDIA. And then last but not least, Dr. Faiza Hidari Kabaz, she is currently working at RBC as Director of Data Science and Data and Analytics. And one of the main reasons that Faiza is the instructor for the machine learning capstone, where you'll be working directly with businesses, is precisely because of her experience in supervising co-op students at RBC in data science. So she was an excellent fit. So with this being an adult or continuing education program, there's no application and enrollment is open. Now, what we do ask, though, is that incoming students do come with a second-year university level linear algebra, calculus, probability, and inferential stats. And we also ask that they come with some program experience and preferably in Python, but it's not necessary if it's not Python, as long as you can code in one language. Now, if you're unsure if you do meet what our recommended requirements are for entry into course 1, we do have a self-assessment up on the Certificate in Machine Learning webpage, and I have the URL just down at the screen there. So as I mentioned, enrollment is open for both the fall 2018 and winter 2019 cohorts. The cost of the program is $6,799, and you can either pay with the minimum deposit or you can pay all at once, and the program fee is due before the first course. Now, if you have questions about the program, you're more than welcome to reach out to my colleague Elspeth, and I have her email up on the screen there. And when you're ready to register for the program, if you have any questions about that, you can contact Allison, and I have Allison's email up on the screen there as well. Now, I will say we don't have any, it's 12:45. We don't have any time to respond to questions in this information session. But again, if you haven't done so yet, I do want to invite you to put your questions into the question box before you leave, and I will respond to those by tomorrow. And again, I'm putting the contact information up here. In case you want to reach out to Elspeth or Allison. Also, of course, if you want to contact me, you're more than welcome to do so. Again, my name is Sean Woodhead. I'm the program manager for machine learning, and my email address is woodhead@yorku.ca. Okay, so I just wanted to thank you all for attending the information session today. And I hope that it's been very informative. And again, one last time, I will respond to all those questions by tomorrow. Yeah, we'll just take it from there. So again, thank you very much for attending, and I hope to see you all in the fall or in the winter. Okay, take care.